Hello there, everybody. This is Miss Arroyo. We are doing another lesson today. Today's lesson is on finding distances. The great thing with Pythagorean theorem is you can find the distance of any diagonal line on a graph or grid by just making a right triangle from that line. So as you notice here, here's my little graph. Okay, so in my graph, I have this diagonal line, and today we want to find out what is this distance or what is this length of this line. We can't just count the squares here because these are going diagonally, okay? So it's not going to give us an accurate distance. But we can use Pythagorean theorem to figure out what that distance really is. Okay, so what we can do is we always want to take the line that goes straight down. I'm going to darken it. Okay, and then the line that goes straight across from the other point. I'm going to darken it. And look at this right triangle we just made right here. So when we make a right triangle, what we're doing is we're looking at this distance and this distance, and we're going to use the Pythagorean theorem, and that's going to help us find this diagonal length. So the way we look at this distance is we look at our graph here. So this hits at 6. This one, if I go across here, hits at 1. The distance between 1 and 6, let's count the squares. 1, 2, 3, 4, 5. So this is a distance of 5. Okay, make sure you're counting the squares or the spaces, okay, and not the lines. All right, let's look across going this way. This way, this point hits at 1. This point here hits at 4, so the distance between the two of them is 3, okay? So we now have our two distances of our legs of our triangle. So I'm just going to redraw that triangle really quick. We've got a length of 5 and a length of 3, and we're trying to find that missing length. So we can use Pythagorean theorem. A squared plus b squared equals c squared. Okay, let's use our lengths and fill this in. Now we are finding the hypotenuse on this length. Whenever we're doing a diagonal like this, we're finding the hypotenuse. So remember, that's always going to be your c squared. So here, our a squared, we're going to do our 3. Now, if I make a square here and I find the square of 3, what is the square of 3? That'd be 3 squared, or 9. Okay, so the area of this square is 9. If I make a square going here with this side length of 5, 5 squared, 5 times 5 is 25. So we've got 5 squared is 25. Then we're going to add these up, and we get our c squared. I'm just going to put c squared here for right now because we don't know what that length is or that area of that square either. We know there's a square here. We don't know the area. We don't know the side length. But if we add these two together, we're going to get 34 equals c squared, okay? And then, again, we can take the square root and figure that out, what actually c is. So the square here is 34, around 34. But we want to find this length here, this question mark, this length, this diagonal. So the diagonal is definitely not 34. So we need to take the square root. So we're going to find c by taking square root of 34. I'm going to take out my calculator. And again, you can use yours. 34 and square root. So that's going to be about 5.83, we'll say. Okay, so 5.83. And I'm going to say approximate. I'm going to use those little squiggle lines. So it's around 5.83, or we could say it is approximately 6. We could round that up to about 6. So this is what our side length would be. It'd be 5.3. And that makes sense. If this length is 5, this is 3. That's going to give us about 5.3 for, or 5.8, sorry, for our length. Okay, so this is how we find distances using Pythagorean theorem. I hope that helped, and go ahead and do your practice. Thank you. Bye.